electric potential energy?
The ability to do work in a field.
And what is electric potential difference?
The change in a potential energy.
And what is voltage?
Potential difference.
What you doing, Brenda?
An equation. This means the amount of work that can be done per charge by an electric field.
Oh, wow! Hey, Nicole, what's a volt?
Oh! A volt is equal to a joule over a coulomb.
Oh, wow! Hey, Kai, what's that?
This is right here. It's a circuit.
What type of circuit?
A series circuit.
What's this?
A battery.
What's this?
A capacitor.
What's this?
A resistor.
Oh, wow! Hey, Nicole, what do these lines mean?
This is a battery. The long side is positive, the small side is negative.
Wow! Hey, Brenda, what's this?
This is an equation for voltage. This is work over charge. Work units are joules, charge units are coulombs, and voltage is volts.
Ow! Oh, gee, I wonder what this is. Huh. Oh, hey, Nicole. Do you know what this is?
This is voltage equals current times resistance.
Wow!
Hey Tyler, I have a
Hey,
question for
Brenda.
you.
Okay, sure.
Can you answer this?
Oh dear, what is the difference between electric potential and electric potential energy? Goodness, I can't answer that.
Electric potential is the ability to do work. Electric potential energy is the charged particle in an electric field.
Wow, that's confusing. How about we do this again, but slower?
Electric potential is the ability to do work. Electric potential energy is a charged particle in the electric field.
Charged particle.
Maybe we can do an example so you can understand better.
Alright, well, what are we doing here?
In this example, we have voltage is equal to 12 volts, charge is equal to negative 4 times 10 to the negative 6 coulombs, and we need to find work.
Okay,
Well, we have this equation, but we
alright.
need to find work.
Oh, that's
So-
true.
We multiply times charge on both sides,
Okay.
canceling out. So now we have work is equal to voltage times charge.
Oh, wow. Okay.
Now we just plug them in.
Plug and chug.
12 volts times negative 4.0 times 10 to the negative 6 coulombs. Can you do that in your head?
That seems like a big number. I don't think so. Let me try. No.
Luckily for you, I have the answer right here. Woo! I've got negative 4.8 times 10 to the negative 5. And then, what's a volt times a coulomb?
A volt times a coulomb. Gee, I'm not sure.
It's a joule.
A joule?
Mhm.
My goodness. So are we done?
Yep.
Wow! Hey Jason, what is one major similarity between the electric field and the gravitational field?
Well, they both have the same formula structure, and I have them right here. For electric field, it's F equals K, charge 1 times charge 2 over R. And for gravitational field, it's G equals okay, times mass 1 times mass 2 over distance. And for a difference, why don't we just go ahead and ask Nicole?
The difference between the electric field and the gravitational field is that the electric field is both repulsive and attractive, while the gravitational field is only attractive.
Wow. Oh, hey Brenda. I have a question for you.
Okay.
What's the difference between potential, potential difference, electric potential, and electric potential difference?
Potential describes the electric fields. Potential difference describes the electric fields.
Okay.
Electric potential describes the electric fields. And electric potential difference describes the electric fields.
Well, good golly, there's no difference in that.
No, they all describe the electric fields.
Oh gosh, I am so lost. A battery is an electric field in a can. Give me a similarity and a difference between these two batteries, aka electric fields in cans.
Well, Tyler, see, both these batteries have the same electric field,
All
with
right.
different potential difference because of their distance.
Oh, okay.
Yep.
Alright, we're using two conducting wires and two batteries with a bulb for a simple circuit experiment for potential difference.
In the first experiment, we will use a 1.5 volt battery, 2 wires, and a light bulb. When we connect the wires to the ends of the battery, we will notice the bulb lights up and provides a dim light. In the second experiment, we will use two 1.5 volt batteries, making it 3 volts altogether, and connecting the wires to the end of one battery and the end of the other. When connected, we will notice the bulb provides more light than in the first experiment when we only used a 1.5 volt battery.
We have a battery and our 2 conductors and our little motor, and it goes from high potential energy to low potential energy to make the motor work.
Hold up! Check it out.
Every electrical device we have in our house uses electrical potential energy, and it gets energy by charges moving from a higher potential energy to a lower potential energy. So think about an electric outlet in your house. Looks something like this. At least in America, there's plugs like this, and there's 2 sides, a left and a right. I'll draw a larger one here. There's 2 little slots here that you stick a plug into, and there's another one. But when you plug in, say you plug in your lamp, you've got your cord, looks something like this, and there's 2 prongs coming out of there, and they plug into those holes, and there's actually 2 wires down inside this cord. One's running to one prong and one to the other, and they're insulated, they don't touch, and they're not exposed to the outside. And so when you plug something in, say you plug in a lamp, there's one wire running from one side and one running to the other, even though they're both wrapped up in the same cord, and they run over here to the lamp, and you have a light bulb inside the lamp, and the electricity runs up here and goes through the light bulb, and the lamp glows. And what happens is electrons are flowing out of one side, and they're flowing along one wire through the bulb and then flowing back in the other direction current later. But what happens is the electrons on one side of this outlet are at a higher potential energy than they are on the other, and they flow from a point of higher energy to a point of lower energy. And the reason they have more potential energy over here on one side is because the power company provides power to your electrons to flow, and they flow from the point of higher potential energy through the lamp to the point of lower potential energy. And in the process, they lose potential energy.
Brenda, did you forget to pay the electricity again?
No, Tyler, I didn't pay the electrical bill. But luckily for us, I have a solution.
Oh no, did you hear that? I think there's something in the room with us.